divide air interface protocols in two parts: user plane and control plane. User plane deals with actual data flow, whereas control plane is used to configure user plane layers before actual data flow. Let's talk about user plane first. When data comes from EPC, it is stored in PDCP buffer at eNode B. So let's first talk about PDCP layer. PDCP means Packet Data Convergence Protocol. First task performed by PDCP is header compression and header decompression of IP data packets. Data packets reaching to eNode B from EPC are IP packets. Each IP packet has a header of 40 bytes. These 40 bytes of IP header do not have any meaningful information, so sending these 40 bytes of header along with actual data on air interface is sheer wastage of resources. Moreover, in case of VoIP call, in which size of actual data is very small compared to IP header, this header is considerable overhead. So we need some mechanism to compress this header. At transmitting end, PDCP layer compresses this header using ROHC or robust header compression protocols. At receiving end, PDCP layer decompresses this header. Second task is maintenance of PDCP sequence numbers. At transmitting end, PDCP layer assigns sequence number to each packet before sending it to the next layer, that is RLC. This sequence number is used by PDCP layer at receiving end to align packets in a sequential order before sending them to upper layers. At the time of handover, PDCP layer of source eNode B sends sequence number of the last packet successfully received by UE to the target eNode B. So the target eNode B can start transmitting data to UE from that packet onward. This way, two eNode Bs can synchronize data flow at the time of handover using PDCP sequence number. Third task is security of the data. If your data is not secure on air interface, somebody may intercept this data. For example, online payment on your mobile will no more be secure if there is no security mechanism. So we need to secure this data by integrity and ciphering before transmitting it on your interface. Now let's come to RLC layer. First task performed by RLC layer is concatenation, segmentation, and reassembly of RLC SDUs. Although header of IP packet is of fixed size, that is 40 bytes, but data part is variable. For example, in case of VoIP call, data part is small, but in case of video streaming, data part of IP packet is quite big. Bandwidth available on air interface keeps on changing very frequently because of changing radio conditions and changing number of EUEs under an eNode B. So RLC at the transmitting end has to concatenate or segment these data packets dynamically according to the current bandwidth on air interface, and RLC at the receiving end does reassembly of this data. Retransmission of RLC PDUs. This is the next task. If data gets corrupted on air interface, then RLC layer of the transmitting entity has to send data packets again. But this kind of transmission is done only when RLC is in acknowledgement mode. Example of AMRLC is data download using FTP. Next task is reordering of RLC data PDUs. Let me tell you the reason for this. Because of